Hello, my name is Xiangci Li. I am an applied scientist at Amazon Web Services and a PhD candidate at UT Dallas. I'm happy to present our work, Relative Work and Citation Text Generation, a survey at EMNLP 2024. Let's get started. To convince readers of the novelty of their research paper, authors must perform a literature review and compose a coherent story that connects and relates related works to their current work. This challenging nature of literature review writing makes automatic related work generation academically and computationally interesting, and also makes it an excellent testbed for examining the capacity of SOTA natural language processing models. In this work, we survey the zoo of related work generation historical works, summarizing the key approaches and task definitions, and discussing the ongoing challenges of related work generation. There are three types of task definitions for related work generation. In chronological order, they are extractive related work generation, citation text generation, and section-level abstractive related work generation. Extractive related work generation refers to generating the related work section of a target paper given the rest of the target paper and all cited papers. This is essentially extracting and concatenating salient sentences from the cited papers to form an related work section. In addition, some works extracted sentences from other works that also referenced the cited papers. The main difference among extractive approaches is in how they order the extracted sentences. Some assumed correct ordering, while some used topic modeling and sentence reordering modules. As a subtask of abstractive related work generation, citation text generation becomes popular because early neural language models, such as pointer generator network and transformers, had severe input length restrictions that is too short for research papers. Citation text generation includes only one or a few cited papers, and mostly used only the target citation text and the cited paper abstract. The main difference among prior citation text generation works is how target citation is defined. It's either single sentences or any number of consecutive sentences, and whether allowing citations shorter than a sentence. Some work only consider citations from a single cited paper, while other papers consider multiple cited papers. Finally, section-level abstractive generation refers to directly generating the related work section of a target paper given the rest of the target paper and all the cited papers. Some works treat the paragraph as the unit of generation, while other works using LLMs generate a full related work section in a single pass. This table is a comparison of the task definitions of extractive and both single citation and full section abstractive approaches to related work generation. You can pause the video to take a closer look. Moving to the approaches of related work generation, there are mainly three steps involved. First, we need to find the relevant documents, which often assumed to be known. Next, we identify the salient aspects of these documents with respect to the current work. And finally, we generate a topic-biased summary as the related work section. Regarding how the cited papers are represented, most of the prior works use cited papers abstract as a proxy of the cited paper. Cited text spans, which refers to the specific span of the cited paper that a given citation refers to, is also a good alternative. In addition, citation graphs, which is local citation network of the target and cited papers, is also a good additional feature. Citation context is also very important. Citation context refers to the text preceding or surrounding the target citation or related work sections. For individual citations, they are several sentences before and optionally after the target citation. For those related work sections, they are full text of the target paper or a few key sections, most commonly the title, abstract, introduction, and conclusion sections. The citation context indicates which topics are salient to the target paper, restricting the related work generation solution space. Citation analysis is also another important aspect of citation generation. Citation analysis can be about citation function, citation intent, or citation sentiment. Prior works from information studies categorized literature reviews into integrative and descriptive writing styles. Integrative literature reviews focus on high-level ideas from multiple papers, while descriptive literature reviews mainly summarize the individual cited papers. Inspired by this categorization, in our prior work, we classified citation spans into dominant and reference type citation spans. Dominant type citations are the main focus of the citation span, while reference type citations, they are tangential to the rest of the citation span. Finally, the ultimate goal of related work generation is to generate a related work section that satisfies a user. While human readers are sensitive to errors in the cited paper organization and emphasis. However, even SOTA LLMs are not capable of organizing and emphasizing a set of cited papers without human guidance. Therefore, human-assisted generation becomes crucial. There are some approaches, such as using keywords for cited text span retrieval or direct generation, or using short summary of main ideas of the target related work section to guide the generation. Alternatively, users are allowed to edit the output related work section. Table 2 compares different related work generation approaches. Some common datasets used for related work generations are ANN, SciSubNet, Delve, Stork, and COA. Note that not all of the cited papers are necessarily in the dataset for a given target paper. Absence may disrupt the flow of the generated related work section. The majority of the related work generation works studied NLP papers rather than papers in other subjects. Finally, future practitioners should be cautious that LLMs may memorize the papers in the past. Figure 3 lists common datasets used in related work generation works. In terms of evaluation, these are the frequently used simple baselines. For the automatic metrics, Rouge is the most commonly used metric, while fluency, coherence, and relevance are the most frequently used human evaluation metrics. Having reviewed the basic aspects of related work generation, let's discuss the lack of comparability issue. We found that work in related work generation is fragmented in terms of task definitions, datasets used for training and evaluation, and how evaluations are conducted. Unlike most NLP tasks, there are no standard benchmarks for related work generation. Moreover, around half of existing works do not release their models or generated citation text or related work sections, making it impossible to reproduce or directly compare approaches. Furthermore, related work generation works do not agree on the definition of citation or related work section. Thus, the target outputs of most related work generation systems are not directly comparable to those of other systems. As we pointed out in our previous work, citations can be longer or shorter than a single sentence, or contain more than one cited paper, so it is unrealistic to ignore citations that are longer than a single sentence or discuss more than a single cited paper. Restricting citations to be single sentences is problematic in the case of a multi-sentence citation, resulting in an information leakage problem. The lack of comparability problem is reflected in the variation in datasets. Many works created their own dataset automatically in an ad hoc manner. Moreover, many works create custom human evaluation aspects. For example, succinctness, factual correctness, and the correctness of citation intent. Finally, as a common limitation and suggestions for future work, citation ordering and organization is underlooked by most of the works. Human readers do not like simple concatenation of cited summaries. As a future work, we suggest automatic citation ordering and grouping. Next, transition sentences and writing style is also underlooked. Previous extractive related work generation and citation text generation did not consider these at all. We suggest distinction between reference style and dominant style citations. The third issue is retrieval-augmented related work generation. Existing related work generation works assume the list of cited paper is available as input, which is definitely unrealistic. As a future work, we suggest to start with a partial list of works that should definitely be cited, alongside a set of candidate works that might be related. Then use retrieval-augmented generation to iteratively select a candidate paper and generates its transition or citation sentences. Last but not least, related work generation involves serious ethical concerns. The first concern is plagiarism or copying and factual errors. Extractive related work generation can cause plagiarism problem, while abstractive generation can cause both plagiarism and hallucination problem. The next concern is academic dishonesty. Is it ethical for a researcher to put an automatically generated related work section in a submitted manuscript? Does this mean the researcher is claiming to have written that related work section as they presumably wrote the rest of the paper? Do the answers to these questions change if the researcher has edited the automatically generated related work section? These are all open questions. Finally, automatic related work generation ignores the value of related work section writing as a learning and thinking experience. To address this, we suggest the human-in-the-loop approach. Thank you for watching.